Alright, so the power rule is kind of nice. It's an easy way to derive functions, and I think the big important part to remember about the power rule is that when you're using it, everything needs to look in this format that you see here. You have to have x to some power, like x to the second or x to the third, x to the nth power, some sort of a power. And so if something's in that format, it's usually really easy to derive. Let's say we have y equals x to the, 7th power. The rule with the power rule says if you want to derive this and you want to find y prime, all you do is take the power and multiply it down in front of the problem. So 7 times x to the 7th power. But not only do you do that, you subtract 1 from the power, you reduce it down. So you get 7x to the 6th power is your y prime. And that's it. That's your answer. Compared to the limit process, this thing's kind of amazing. The limit process would have made this so much more difficult. We would have had to use Pascal's triangle, multiplied it out. It would have been a total mess. So that's it. You got your answer. And we can try a bunch of different types of these and kind of show you they're not all the same. Like, let's say over here we have y equals 3x squared, and you're going to power rule it. Well, that's going to be y equals 2 times 3x squared, but we're going to subtract 1 from the power. So 2 times 3 is 6, and we're going to end up with x to the first power. And I'm not really going to write first power. I'm going to erase that because nobody really writes first power. We're going to write y prime equals 6x, and that is our answer. Y prime equals 6x. So the weird cases are things like this. So another example here for you. Let's say we have y equals the square root of x. In my mind, this does not look like the power rule, but I'm going to rewrite it. So before I derive it, I'm just going to rewrite y equals, and the square root of x is really the same as x to the 1/2 power when you think about it. So now it looks like the power rule. I can do this. I'm going to find the derivative. I'm going to find y prime. Well, multiply the 1/2 down. So 1/2 times x to the 1/2 power. And then subtract 1 from the power. And so y prime is going to equal 1/2 x. And then 1/2 minus 1, we got to do this math. That's going to be negative 1/2. And we don't really like negative powers, so I tend to want to fix these problems when you have a negative power. And what I'm going to do to fix it is I'm basically going to rewrite this as y prime equals, and I'm going to change it to 1 over 2 x to the 1/2 power. Moving this variable down turns it into a positive power. So essentially this is going to be your answer right here to this problem. So like this next example is y equals 4 over 5x squared. The strategy again is going to be to rewrite this, and what I'm going to do is, since this is in the bottom of the fraction down here, I'm going to move it up by making it a negative power. I'm going to rewrite it as y equals 4/5, and then it's going to be on top x to the negative 2 power. And now I'm ready to power rule it. So in my next step, I'm going to find y prime. And I'm going to multiply the negative 2 down, so negative 2 times the 4/5, and then x to the negative 2, and we are going to subtract 1 from the top power. So we're going to get y prime equals negative 2 times 4 is negative 8/5, and x to the negative 3 power. Negative 2 minus 1 is negative 3, which could be an answer, but we don't like negative powers. So what I'm going to do is I'm going to go over here and rewrite it as y prime equals negative 8 over 5, 8/5, but I'm going to put the x to the third down in the bottom of the fraction, and that is going to be my final answer. No negative powers, and I'm happy. So these types of problems you can combine to make them larger. You can do lots of different things, so I'm going to make up another example here. We'll say example 4. And what I'm going to show you is, like, you can combine this into multiple things. So like you could have y equals, and you could have something like x over 3 plus 2x to the 4th minus 5. And I could say derive this thing, derive the entire equation. And what you'll do is you'll basically power rule every single one of these pieces here. You're going to have 3 power rules to kind of tackle and do. So that's going to be my plan. I'm going to power rule every single piece. I'm going to erase these because we don't need these arrows. And so first, before I do that, I'm going to go for a rewrite step here. I'm going to rewrite y equals, not deriving it yet. This first piece here, I'm looking at it thinking maybe I need to change it, x over 3. Let's rewrite it as 1/3 x to the first power. It's the same thing. It's a 1/3 x over 3, plus 2x to the 4th, I don't need to rewrite that, minus 5. And to be honest, I'm kind of thinking about this minus 5 a little bit. It's just a number. There's no x involved. So if I wanted an x involved, what I could do is I could put an x to the 0 power. Because technically x to the 0 is nothing. I mean, it's 1, but it's not there. So this really technically has an x to the 0 in the problem. So now I'm going to find my y prime by going through and power rule this, and power rule this. 3 power rules. So 1/3 x to the first power, well, I'll multiply the 1 down. 1 times 1/3 x to the first power, subtract 1. Plus 2x to the 4th, I'll multiply the 4 down. 4 times 2x to the 4th, and then I'll subtract 1 from the power. Minus, bring down the 0. 0 times 5x to the 0 minus 1 from the power. And we're going to clean this up. So we've got y prime equals 1 times 1/3 is 1/3. X to the 1 minus 1 is x to the 0. X to the 0. And if you think about it, x to the 0 does not need to be written. It doesn't need to be there. So what I'm going to do is I'm actually going to erase x to the 0 and just not even write it. And then I'm going to keep going here. Plus 4 times 2 is 8. And it's x to the 4 minus 1 here. So we're going to have x to the 3rd. Minus 0 times all this stuff. Well, 0 times anything. I mean, this is all going to cancel to a 0. So since it's all a 0, usually we don't even write minus 0. And I'm going to really say that all of this is my answer. 1/3 plus 8x cubed. It turns out, in this situation, when we had this minus 5 up here at the top, anytime you have a number, it's the same as having an x to the 0. So the derivative is always going to do this situation where it cancels out to nothing. Derivative of a number ends up always being 0. So try this one. Next example. Let's see, that was example 4, so example 5. If you had y equals 7x plus 3, what would the derivative be? So think of it like this. This is 7x to the first power, if you really wanted to think about it like that. And this is 3x to the 0 power, if you really wanted to think about it like that. So my y prime is going to be 7x, so we're going to do 1 times 7, x to the 1 minus 1 power, plus 0 times 3, x to the 0 minus 1 power. And it turns out that 0 times all this is going to cancel. And we have 1 times 7 is 7. X to the 1 minus 1 is 0 equals y prime. And since x to the 0 is really like not needing to be there, we're going to write y prime equals 7. And that is your answer. Y prime equals 7. So that's a little video on power rule. We'll practice it a lot in class. You'll get really good at it quickly, I hope. Yeah, so I hope that helps.